students, and welcome to my channel Study Circle. Today we are going to start the introduction part of the Quadrilaterals chapter. And students, if you have got any queries or any doubt related to my video or any problems you didn't understand from the textbook or Adi Sharma, please mention it in the comment section. So now let's get started with our topic today, that is quadrilaterals. Before I explain you what is meant by quadrilaterals, we'll just discuss about what are collinear and non-collinear points. Okay, so let's consider 2 points like this. Let's name them A and B. Now students, what happens if we join them? If we join them, we get a line segment like this. Similarly, if we have 3 points like this, let's name them A, B and C. If I join them, I get a line segment AC or AB or BC, all of them are line segments only, right? So when the points, when they lie on the same line, they are said to be collinear. So 2 or more than 2 points, when they lie on the same line, they are said to be collinear points. Alright, so what happens when they do not lie on the same line? Like these 3 points, A, B and C, they do not lie on the same line, right? What happens when we join them to make a closed figure? When we join them to make a closed figure, it forms a triangle, right? So these points which do not lie on the same line are called as non-collinear points. I hope this topic collinear and non-collinear is clear to you. Similarly, if we have got 4 points like A, B, C, D, again these points, they lie on the same line, therefore they are called as collinear. And if they do not lie on the same line, A, B, C, D, these points, they do not lie on the same line, right? So what happens if we join them to make a closed figure? We form a figure like this. So when we join 4 non-collinear points A, B, C, D, we form a closed figure with 4 sides. So this closed figure with 4 sides is called as quadrilateral. So this is what is known as a quadrilateral. Now the 4 points can also lie in this manner, like this. Students, this is also called as a quadrilateral. A, B, C, D, let's name them A, B, C, D. So this is also called as a quadrilateral. There are 2 types of quadrilaterals. This quadrilateral is called as convex quadrilateral and this quadrilateral is called as concave quadrilateral. The difference between convex quadrilateral and concave quadrilateral is that all the angles in a convex quadrilateral, it is less than 180 degree. But the angles in a concave quadrilateral can be more than 180 degree. Like for instance, in this figure, if you extend this line, you will see that this is 180 degree. But the angle formed by CDA, this angle, this entire angle, the reflex angle of CDA, it is more than 180 degree. Right, students? So we can see that one of the angle in quadrilateral ABCD is more than 180 degree. So this is called as a concave quadrilateral. So you need not worry about the concave quadrilateral for now because we don't have concave quadrilateral in our syllabus. We are just concerned with the convex quadrilateral. So this is all about the introduction part and we will learn what are the different types of quadrilaterals. Okay students. Now I think you are familiar with what are quadrilaterals. A quadrilateral is any polygon with 4 sides. So these are the different types of quadrilaterals. You can see that each of them have 4 sides, right? So trapezium, parallelogram and kite. Now this parallelogram is further divided into 3 types. Like these squares, rhombus and rectangles, these are called as the special types of parallelogram. We will one by one study the different properties of different quadrilaterals. So students, this is a trapezium. In a trapezium, one pair of opposite sides are parallel. Like here, if we name them to be A, B, C and D, then AB is parallel to DC. And the parallel sides are called as bases and the non-parallel sides are called as legs. So here AB and DC are called bases AD and BC is called as legs. And in a trapezium, no sides, no angles and no diagonals are congruent. Means no sides or angles or diagonals are equal in trapezium. Now let's talk about parallelogram. In a parallelogram A, B, C, D, the opposite sides are parallel and equal. That means AB is parallel and equal to CD, AC is parallel and equal to BD. And in a parallelogram, opposite angles are equal. That means angle A is equal to angle D, angle C is equal to angle B. And the adjacent angles are supplementary. That means when I add angle C plus angle D, I'll get 180 degrees. And similarly, if I add angle A plus angle B, I get 180 degrees. Even these are adjacent to each other. So angle B plus angle D is also 180 and angle A plus angle C is also equal to 180 degrees. And in a parallelogram, the diagonals, they bisect each other. So when they intersect here, we can say that AO is equal to OD and CO is equal to OB. So these are the properties of a parallelogram. Now let's talk about squares. Square is a special type of a parallelogram. Okay, all the sides in a square are equal and also all the angles are equal. In a square, opposite sides are parallel and also equal. If these are the names of the vertices, then AB is equal and parallel to CD, AC is equal and parallel to BD, and also all the sides are equal. That is, AC is equal to CD, is equal to DB, and it is equal to BA. The diagonals, they bisect each other at 90 degrees. So if this is a square, then diagonals, they bisect each other at 90 degrees. So they are equal and also they bisect, they are perpendicular to each other. This is a rhombus. This is also a special type of parallelogram. The difference between square and a rhombus is that here the angles are not 90 degrees. Okay, here all the angles are 90 degrees, but here the angles are not 90 degrees, they are less than 90 degrees. Okay, so all the sides are equal, opposite sides are parallel, opposite angles are equal, so it is similar to parallelogram, and the diagonals, they are perpendicular bisector of each other, similar to the square. The diagonals, they bisect and they are perpendicular to each other. Now rectangle is also a special type of parallelogram. Here also the opposite sides are parallel and equal, all the angles are 90 degree and the diagonals, they bisect each other. It is similar to parallelogram. The only difference between parallelogram and a rectangle is that here the angles are 90 degree and in a parallelogram the angles are not 90 degrees. So there is a kite. The properties of kites are two sets of adjacent sides are equal. That means if AB is equal to AD and BC is equal to CD. One more property is that one set of opposite angles are equal. One set of opposite angles are equal and those angles should be situated in between two unequal sides. That means these are the two unequal sides. So angle over here is equal to angle over here. These angles are not equal. The angles which are equal must be situated in between two unequal sides. So angle B is equal to angle D. Only one diagonal is bisected. That means if I draw two diagonals like this, then only one diagonal, that is this angle is diagonal is bisected. That is BO is equal to OD. Alright, and they bisect each other at 90 degrees. So they form a perpendicular like this. So these are different kinds of quadrilaterals. So students, this is all about the types of quadrilaterals. I hope this was clear to you. And you'll find a number of examples around you, the different types of quadrilaterals like paper or the kite which you are flying. There are innumerable types of examples in front of you. You just need to look around and identify them. And please like, share, and subscribe to my channel for more videos. I'll soon be uploading the other part of the quadrilaterals chapter, and make sure that you don't miss it. Thanks for watching.